Hello, everyone, and welcome to Chapter 1. What is Octane? And I feel like this is obviously, y'all might be rolling your eyes at this question, but I feel like a lot of artists use this program but don't actually understand what it is or what it does and really what it's for. So let's talk about Octane in general, or Otoy as a company. Otoy's main goal, and as far as the press conferences that I have seen, is to have 3D rendered holographic, like holo rooms, holographics. That's really something they are working like at a sprinting speed towards. And part of that is rendering. So as a result, they have a render engine. And I think this is really the reason they started it in the render engine. They saw a need for unbiased, which essentially is a loose term for saying photorealism. Not exactly. There are biased engines that deliver photoreal results, but they wanted to go this direction. So they wanted to go towards unbiased photoreal rendering on a graphics card. This is never really heard of before them. Yes, there are examples, but they really took this to the next level. And you can see that right here. Real-time 3D rendering, the world's first GPU-based physically correct renderer. Okay, so they're working towards that, and as a byproduct, we have this render engine that's great in the visual effects industry. Awesome. I just wanted you to understand this because at times it can feel like they're a little bit behind on updates or stability, and that has a lot to do with their code running improperly with CUDA cores because of the, I think it was Vulkan they chose to code for when they really should have been coding for a different API in hindsight. And I'm just talking about the press conferences that I've seen them talk about this. I am not in any way a writing for drivers or writing for render engines or anything in any coding sense. I have a very little understanding of it, but I just wanted to share that information with y'all so you can understand, hey, this is why we have this program, and this is this company's ultimate goal. And because of that, we have these awesome features like for example, render token. If you don't know what render token is, it's just now at this time of this recording kind of becoming public knowledge or open to the public artist, but it's essentially a decentralized GPU network that allows you to send your scenes to render, and you pay in tokens. It works on the blockchain. It's going to be awesome if they can pull it off, and it looks like they are. And we'll talk about that later on down the line. This is just kind of a background information on this company, and it's really for those of you that maybe just now heard about Octane, like you're just now getting into the industry of 3D graphics, or you wanted to maybe just learn a little bit about Octane. I wanted to give you some background information. And you can check all this stuff on their website. Really awesome stuff. There's some Ash Throp's work. Super, really cool. Check it out. Check out the features. I just wanted to give y'all some background information before we just jump right into the program, because it's important to know what the company's goals are and where they're heading with their stuff. And yes, they're heading in visual effects for sure. Like, that is the direction they're taking it, but they have bigger goals as well than just being a render engine. So I wanted to share that with y'all, and we'll move on a little bit to just kind of the program and how to use it. So just to recap in layman's terms, what is Octane? It's a unbiased GPU render engine that delivers fast photoreal graphics. Okay, now that we know that, we'll be moving on into Cinema 4D. Again, guys, check their website, check for updates. I really think it's interesting to follow them in their journey towards their goal. They are a huge company, and they're doing some really cool stuff in the industry. So I'm excited for that. But I wanted to share that. I think that's a little fun background information. Okay, enough of that. Let's get started. What I'm going to be going over with y'all is the render view, the Octane object tag, the Octane materials, and the global settings. And we will just be touching lightly on everything. There will be larger chapters dedicated to these things further on, and we'll dive deep into the creative side. But this is the technical side right here. We're going to be learning the technical first. So I'm going to open up Cinema 4D, and we'll get right into it. Okay, so first things first, let's go ahead and open up Octane. After you install it in your program files folder, you can get to that right here, file, and then we'll just go to, edit, preferences, and then under the preferences folder, you can open the preference folder and you'll find your plugins right here. Let me pull this over. And it's right there. You can install it through there, or you can just go through the regular file system to get to it. Either way, it'll work. Just drop the Octane all the files in right there. You'll have it. Restart Cinema 4D, and you get Octane right here. And this is our live viewer window. So let's go ahead and open that up right there. It comes out just like that. We'll just grab it right here, dock it to the left, punch the little render. And there we go. We got our first render going. So let's just go ahead, drop in a plane, and then drop in a cube. Cool. This is just so we can see kind of what's going on with all of this. So here we go. You can notice I'm running on 12080 Ti. Pretty good graphics card for the time. 3080s are coming out soon. Really excited to see what those do. See how quickly we resolve that noise. And you can just rotate right here by doing this. And if this is basic for some of y'all might be more experienced users, feel free to put this in fast forward or skip through, but I will be touching on the basics. So just for those of you that don't know, and I might be touching on something you know a lot, but you might not know what I'm touching on. So you might want to stay around for that. So let's go ahead and open up the Octane settings right here. Octane settings, there we go. And then we get our render kernel right here going. So really what this allows us to do is change the type of light calculation we're having. So if I go to let's create an HDRI environment. I'll touch on all that in a little bit. It's gonna turn it dark. Let's go to Octane right here, and then let's go to light. Let's add an area light, and I just want to drag this out right here. Cool. Just so we have some lighting going on, and we have just a really crude calculation of light happening here. We have these different settings. We have direct lighting, info channels, which is, this is really not necessary for you to mess with, direct lighting, and then we have samples right here. So if we turn this down and then re-go, you can see it's really noisy, and this is really low for sample rate. So as we turn this up, we get less noise and it starts to calculate out. And I will tell you this, you'll get more changes lower down in the samples. So for example, from going to something like 1 to 2, let's do that real quick. So here's 1, here's 2, there's a huge change. But from going to like 200 to 201, so here's 200. And there we go, just like that. And then here's 201. Let it calculate back. You can see that there's not a huge difference between 200 and 201, but there's a huge difference between 1 and 2. So what that tells us is as we move up, we're kind of getting a logarithmic diminishing returns on how nice our renders look. So this is important to understand for when you're rendering animations and stuff. You might have to be doing some denoising and stuff, because if you need to go to 500 to 600 and you still have or 5,000 to 6,000, you still have a bunch of noise, it's not going to help you that much to go to 6,000 to 7,000. You're going to start implementing different methods than just cranking this up, unless you want ridiculous render times. And for this simple scene, you can see it's starting to take a little bit. And this noisy image is great for the preview. It previews so quickly, but when you're rendering, you want it to look clean as possible, and your clients want it to look clean as possible. So we'll talk about cleaning that all up. I just want you to realize, hey, the higher you go with this, you're going to get diminishing returns. You're going to lose a lot of speed. You're going to lose a lot of speed of the engine, and it's going to take a long time to calculate, and you're not going to get really great results as you get higher and higher. I like to stay under 5,000 samples as a general rule of thumb for direct lighting, but sometimes I have to go over because of the scene, even with denoising. So that's that. Okay, so there's these different GI modes. So direct lighting is the least amount photoreal out of these. There's direct lighting, path tracing. You can see, look at that. Look how it lit up the difference. Dark right there, and then it lights up. It gets all our bounces, and then PMC. You want to use PMC very, very, very rarely. You can see how long this is taking to calculate. This will take a long time to calculate, and it's so noisy still. So really use PMC. You'll know when you need to use it because you'll be on that level of where you're working so closely with the engine. You're going to be knowing what you're looking for, but mostly for caustic reflections and really just dealing with caustics and certain reflections and stuff and certain bounce lighting, you'll need PMC for. Well, I wouldn't say you need it. I would never subject you to saying you need this. If you're delivering a specific product where it requires caustics or something and it's a still, you might want to use PMC then, but for now, we will not be ever using it. It is ridiculously long render times, and they're in almost every single case, you will not notice a difference between PMC and path tracing, or even PMC and direct lighting, and we'll talk about these different GIs. So this is direct lighting ambient occlusion. And you can see right here, okay, we don't have that much bounce going on right here. This does not look photoreal for many reasons, and one of them is the lighting. We should be getting a bounce, guys. Like, you know, you study light, you see light in the real world, you would expect there to be some light bouncing off this, but because we're on ambient occlusion, there's not. So what we need to do is switch to diffuse. So that's great right there. We got that. Now that we have diffuse going, we got this bounce going up, and it's really not too heavy on our render times. We get a really great result for really not trading off that much speed. And then you have, let's scroll down right here, none. And I don't even touch on none because it's so ridiculously bad. I just wouldn't use it. And you can see it's not that much faster than ambient occlusion. And on a lot of times they look the same, and obviously diffuse. So if I were you, I would ride with GI diffuse almost for everything. There is path tracing right here, and this is really great for stills. You get a lot more hot pixels. We'll talk about all this later, but just know I only use path tracing for stills or in certain circumstances with working with volumes. Sometimes I notice a benefit to path tracing that I'm willing to trade off for render time. But a lot of times path tracing generates a lot of issues with hot pixels, GI noise. You'll notice a lot more of that with path tracing. So for now, we'll be doing most of our work inside of direct lighting. And then we'll be doing a GI diffuse because it has the most bounces and stuff. And you can tell there's not really a big difference between even direct lighting and path tracing. These direct lightings, I'm not sure if a lot of people know a lot about them. I sure don't. But essentially, they're kind of like path tracing hacks. They take shortcuts and stuff, but it really doesn't. A lot of times you can't notice a difference. So these shortcuts are, in this case, really good. So yes, technically we are not like ray tracing completely like you would expect, but I mean, at this point it's so photoreal we wouldn't be able to notice the difference. So I just wanted to touch on that whole thing because I get so many questions you wouldn't even imagine on render settings, and we'll touch on the full render settings, but I just wanted to explain those differences. So working here on forward, when we do a render, you kind of know, hey, these are the kernels to work with, and this is why I kind of stick with direct lighting GI diffuse. Okay, so now let's move on to the live viewer window right here. I kind of jumped in the settings, but you can access them by clicking that button right there. You have them all right there. And then we'll go deeper into these later. But for now, let's focus on the live viewer window. So as you can see, it updates. If you don't want it to update for whatever reason, you can pause it right there. You can restart the new render. Sometimes you have to do that when adding materials. Not so much now with these newer versions, but maybe in the future they'll bring that back where you kind of have to refresh a little bit to get your materials back, and then you can send your scene to again, and when you do that, it kind of reloads all your textures and geometry back into the scene. So that's how you do all that. We can lock this to our resolution. So if we do that, let's go to Octane up here. You can see if I were to do like 500 by 500, so let's do 500 here, 500 here. Let's unlock it, lock it back. Now we have a 500 by 500 pixel render right there locked, instead of it just snapping to everything. Because if you notice, we'll lose our square aspect ratio when pulling out. And then pushing in, it kind of just does these lines right here. So sometimes it's nice to kind of lock it down, especially if you're working on a second monitor. And then we have our material. So this is different modes. There's clay mode, and then essentially just non-clay mode. This would make more sense if we had materials on our scene, but yeah. And then render region and render view. So if you do this, you can render the region. Let's click out right there. So what is this tool? It basically just gives you render window, and when working in bigger scenes, you'll want to use this because they'll take longer to resolve the full scene, and you might just be working on one material in one part of your screen. So you just want to zoom in right there, or not really zoom in, but just kind of window it right there and get it resolved. Look how fast it cleans all up that noise. And if you're working in heavier scenes, that's going to be so helpful. Versus this, it takes a while to resolve. If you're only focusing on like a portion of the floor, like you want to get a certain reflection off of it, this is great for stuff like that. Focus right here, you can just click focus. We don't have any kind of cameras going on right now, so not important for the current lesson, but letting you know it's there. And then we have this right here, and this is so much confusion is about to happen. So these are different color spaces, and there's ACES right here, linear 8-bit, HDR. This is not what you're rendering in. Don't get that confused. This is just kind of like display helpers right here, tone map types. It's basically tone mapping the data from a color space to your screen. So right now we don't want to tone map anything. My monitors are 8-bit plus or like 10-bit minus. That sounds kind of weird, but they're not full 10-bit essentially. So I just use a low dynamic range 8-bit. I don't have a super high like 1000 nit monitor. If you did, you might want to do HDR. And you'll know if you're buying that kind of gear, you'll know if you have it or not. And then ACES, this is really just for working in CG. I don't think anyone's screen can display ACES right now, except maybe for some crazy industry ones, but I doubt anyone has those right now. So you don't have to worry too much about tone mapping to ACES currently. So low dynamic range, 8-bit, cool. And you can also just change your kernels right here. So you can go path tracing, PMC, color, alpha, Z depth, UV, normal, and wire. Wire is great for seeing how much geometry you have. You might notice like you have a ridiculous amount of geometry in a certain part of your scene that you didn't realize, and you're like, oh, that's killing my render times. Let me delete that object, or let me polygon reduction that object. That's why this is here, and it's just great to kind of troubleshoot your scene. If you have slow render times, hey, maybe check your wireframe. You might have this crazy geometry complex structure that doesn't have to be like so much like that. So we'll go back to direct lighting right there. Again, here are your settings, and we'll go over these render settings later, just letting you know here they are. Camera imager, so you can change your exposure right here. We don't have a current camera on, so it's just going to tone map our display output essentially. Highlight compression, this is great. I'm just going to brush over all this. We'll get into further detail on the camera section. Just want to learn more about this stuff, jump over there. Then post settings, so we can enable that through here. Look at that bloom. Bloom is great. It gives you a nice highlight roll off. Different settings right here. Again, we'll touch on that further, just letting you know, hey, they're here. And then, okay, so some of you might have multiple GPUs that all appear here. You can say, hey, use this GPU for the render. Use it as a priority. That means override all other programs using it. Right now in this computer, I only have one GPU, so I'm not going to prioritize it because I'm also screen recording. It might make that screen recording choppy. Used for tone mapping, used for denoising. Render priority right here, high, medium, low. You can change right there and then click use priority if you want. If you have multiple GPUs, it might be a good idea to take one of them offline for the developmental process of your project, because it will kind of save you time in moving around your system, especially if you're referencing images or watching tutorials on the other screen or on the side. But it's not necessary. You can keep them all online if you want. Just letting you know that's where they are. If you have really slow render times, you have a lot of GPUs, check this. Because you might not be using them all. And this is account stuff. Really, all this other stuff, you don't really need to touch this. Leave it to the developers, and then you can change the color of your stuff if you really feel like it. But I mean, it's fine. The defaults are fine for me. So now that we've kind of touched on the settings and everything, we've touched on the viewer. Real quick, I'll show you how to create some materials. So you can go up here and do materials, and you can choose Octane, diffuse, glossy, specular, metallic, universal, hair, tune, mix, composite, which is a newer one, or layered, and then also portal. We'll talk about all these later, but for now, there you go. You can also convert materials from Cinema 4D to Octane, remove unused materials. That's nice for just getting rid of materials. If you have a lot in your scene and you've deleted some stuff, you don't need them anymore. And it can save you some optimization. It might be loading them into your GPU memory, which is unnecessary if they're not in your scene. Duplicate and then empty texture cache. You could do that if you're having some crashing issues, but it's not a huge thing to touch on at all. And you can also create materials down here. So we can go to create, and then we'll go to extensions, plugins, C4D Octane, and then Octane material right there. So you could do it up here or through there, or even I believe up here, C4D Octane, and then, well, we have more settings right here. So these are kind of different, but you can create them through here and down here. Perfect. So double click your material to open it up, and you'll notice you have all your different parameters of the material, just letting you know it's here. And a lot of the times I for most of this class, if unless I need to just quickly change the setting, we'll be working in the node editor. So let's click the node editor right here. Node workflows, so much more powerful than this layered workflow. You can do so much more, and it's more visual. For me as an artist, I enjoy the node editor so much more than working here. Because I like to work visually and I map everything in my mind in space and visually. So this node editor helps me so much more. It's easier to do that for me than here. You can of course work in this for simple textures and materials, but for advanced stuff in the node editor, and for this class we'll be working mostly in the node editor, unless you just need to change your roughness or something real quick. Throw it on, just change it, and then there you go. But we'll be working in the node editor mostly, just letting you know it's there. And if you're scared of it, don't be. We'll completely break it down from start to finish, but this is how you access it. And finally, let's talk briefly on the Octane material tag. So we'll click right here, and we'll go to C4D Octane tags, and we'll do Octane object tag. Sorry, not material, object tag. We'll click on that right there. And then you have all these different settings. So you can change your motion blur of an object. This is useful for really kind of a niche cases when your camera is moving with your subject and you're getting some weird motion blur. You might want to check some of this out because that could potentially help you. If you have a motion blur issue and your subject and your camera is moving, go here first. This is your first troubleshoot because most likely this will resolve it. We can also change visibility of objects. So we have in our cube right now, we can take our general visibility, pull it down, and it kind of becomes like opaque, and then we can take it all the way down to 0, so it's not going to cast any shadows, any reflections, any diffuse. We won't see it, any caustics, whatever you're getting from it. We'll turn it back up all the way. We can also just turn off camera visibility. So you might notice now, hey, we have this cube here, but it's gone, but we still have the shadow. This is really great for visual effects work. If you needed like a shadow in your scene or something, but you don't want to see your object, this is something cool. You can also get some really interesting looks out of this, but you want to be careful because you can kind of pull yourself out of that photoreal graphics that we're going for, because in reality, there's nothing that in the real life that would cast a shadow and you not be able to see it at all. So there we go. We can also turn off shadow visibility. So there you go. Gave us this really weird floating look. Again, you might use this in some visual effects, but maybe not. And then dirt visibility. Obviously, we don't have any dirt in our scene, so we're not going to be needing that. Object layer. This is great for multi-passes, letting you know it's there. We'll talk about that later. Subdivision. You can subdivide your geometry. So let's do that real quick. Let's go into the wire mode and let's subdivide it. So now you can see we're subdividing it, and there we go. And you notice if you subdivide a cube in a certain way, you'll get a sphere, and that's what just happened. There's different, and it looks like we kind of broke it. So let's refresh. Hope for the best. No crashes. Great. Change the subdivision levels just like that. There's Catman Clark right here. There's a loop, bilinear. So right here, if you want to retain your shape, we can still get more detail on this cube. So there you go. And this is a cube. You're not going to get like a crazy result from it. But if we had like a model that really wasn't modeled the best, or really you wanted to subdivide it, you could, instead of doing it in Cinema 4D, do an Octane, which Octane handles geometry a lot better. And then you can change the sharpness of your subdivision. Really fun little tag and can be really useful at times. So letting you know it's there. And then we have hair. So this is really used for like splines or X particles, and you wanted to kind of like render a hair out of it. This is the tag you would use. We won't touch too much on this, but letting you know it's there. It's an option, because for me, it took me forever how to figure that out. So I thought it'd be helpful to kind of share that. And that concludes the first kind of introduction to Octane. just like how it works, this is like the first little part. We'll move in slowly to the node editor and kind of talk about materials and be working in a scene. So we'll jump over and start doing that. Okay guys, so this project is under your chapter 1 project files. So here you go right here. And I thought it'd be fun to make a little cool promo, not only for like the graphics and everything, but also just to show y'all, hey, this is what we're touching on in the lesson, and this is how you can kind of use these elements. And I thought it'd be easier to kind of teach y'all through an actual scene that looks pretty decent, instead of just like talking about cubes on surfaces and stuff. I think this is a lot more applicable. So we'll be touching on the node editor. We won't be going into like super advanced procedural workflows or anything quite yet. We're just touching on everything in this lesson. So let's go ahead and create a new material. So let's go to create, and then let's go to extensions, plugin C40 Octane material. There we go. And just for the sake of this tutorial, let's throw it on our geometry right here. It's going to update it, and there we go. We have our new geo, just like that. So double click it, and you'll get this pulled up right here. So Octane has some different materials. We have a diffuse material, a glossy material, specular, which is glass or anything see-through, metallic, and this is for working with metals, obviously, and we'll be diving into all of these like IRR modes and stuff and how to get really cool looks out of it. For this particular material, I think I did like RGB IOR and did something like this, and then gave it a roughness with a map, a grunge map. And then Toon's really fun. We'll talk briefly on Toon. It's really cool, and you can get some really cool stuff out of it, and I'm going to be working with it a lot. So maybe in the future videos, we'll talk a little bit about it. And then in personal projects, I'm working with it a lot. Not for these tutorials, but just letting you know it's there. Obviously, not going to deliver you photoreal results, but you can have some fun projects with it. And it's really, really fast, so much faster than any of the other materials because they're so simple. So let's talk about, most of the time you're going to work with glossy from an artistic perspective. Maybe not from a photoreal perspective, but from an artistic perspective, I like to work with glossy because you can see how this floor becomes so much more dynamic when it's glossy because we got that glossy reflection coming off of it. So let's jump into the node editor. Here it is right here. And I'm going to be loading in some textures from Quixel Bridge. And just to let y'all know, a lot of times when you drag your textures directly in here, like I'm going to be doing, you might get a couple of crashes. I usually get more crashes when I drag them in like that. So we're going to get a basic material from Quixel, and let's just click on it right here. You can see when we open it up, almost all materials will have these. Some might have some different parameters depending on the material, but you'll have an albedo, your color, ambient occlusion, which you multiply with your color, a displacement, and that's just to displace the geometry. A normals and displacements, they might be a little confusing. They're essentially doing the same thing, except displacements are actually displacing your geometry. Normals are giving you fake shadows. They look the best when working together with each other, but a lot of times displacing will slow down your renders and give you hot pixels, really just give you a lot of issues in general with render times. So the rule is basically if you don't have to displace, using just a normal. And then roughness, this is going to tell our object, hey, how does light react on this surface? Roughness is probably one of the most key components of creating like a realistic material, I would say, because it gives you that surface imperfection. Of course, all of these play into that, but roughness is really the biggest one that you can target right off the bat to make it look more photoreal. So I'm just going to drag these in right here. So I'm going to drag in the color, just like that. The displacement, the normal, and the roughness. There we go. So let's plug the color right here. And for the purposes of this video, I'll go ahead and drop this onto our floor. So there we go. We have this perfectly glossy surface, but not for long. Let's go ahead and route our color in right there. And you can kind of see it's changed how reflective the surface is, or how receptive the surface is to light. It's a lot darker than it was before, so everything's kind of playing off of it a little differently, and it changed our lighting. And you'll hear me talk about this a lot, but like lighting and materials are super closely linked together. So as you'll discover that as you play along, or if you haven't already, a more experienced 3D artist will tell you that right off the bat. But it took me a while to figure out, so I'm just telling you all right now. If you have a problem with your scene, it's not looking quite how you want to look at it, troubleshoot your lighting and troubleshoot your materials, because they're probably the issues lying somewhere in there. Also, composition, everything plays a big role, but you can get lost in the technical side of materials. So here we go, roughness right there. Now look at that. It gave us that surface imperfection we were looking for. Maybe didn't make it look any better, but it kind of, now look how the light plays off of it. It kind of disperses. It looks like an actual surface versus a sheet of glass. And then here is our normal. So we'll plug that into the normal right there. Bump maps, just to let y'all know, if you have a bump map, it's basically a grayscale normal. Just FYI, if you wanted to know that, you know it now. Displacement. There's really no difference in quality between bumps and normals. Displacement's a little, I would say, a pain in the butt. No, it's a little special, so we need a displacement node for that. There's two ways to get that. You notice we have all our nodes right here. There it is right there. Or we can just go up here and just search dis. And I'll get it. I'll spell it right eventually. Displacement, drag it in right there. Drag it into the texture, then drag it up right here. There we go. It's going to update our scene. Okay, something crazy happened, as things do with displacement. So first thing let's do is let's take that height down to 1. Let's take this right here. This is the level detail. We're going to do 8K because this is an 8K texture, and there you go. It fixed it. And I just realized that's really weird. We're getting some weird results. I had dropped the same material on our guy as the floor, so that's why we got that weird result. But now we're displacing our geometry, and this will change with how we scale it. So obviously right now this 8K texture is being stretched too much. So let's go ahead and do the tiles from 1 to maybe like 5 and 5. Looking a lot better. We'll maybe do 6 and 6. And that looks pretty good right now, and it's really not, you can't notice the tiling or anything. And let's go ahead and just take this displacement height, pull it up. And to see what your displacement's doing, go ahead and disconnect your normal or bump, and you can see really what it's doing. So it looks like it's not doing much. So we'll crank it up a little bit more. Okay, took it up a little too much. And then change that mid-level down. If it starts moving around too much, you might want to move your mid-level. And it looks pretty good right there. Let's plug our normal back in. There we go. So now we're kind of getting that surface that we're looking for. And that's how you would build a simple material based off of image textures right there. You might, depending on your material, it might have some different parameters. But for the most part, you'll be dealing with just these 4. And that's about it. So let's go ahead and close that. And let's just go over the scene real quick. So I'm going to delete this. And I'm going to walk you through what I did. For many of you, I mean, this is no crazy scene or anything, but I thought it served the purpose for the lesson, so I just did it. I'll open up the node editor right here. And let's just talk about what's going on, and let's break down all this stuff. So essentially, I have a floor material and material 2. For some reason, this one's called floor because I decided to name it, and I added this material in because I needed some more surface imperfections, and it was tiling a little too much. So you can notice the repetition of the material, which is a dead giveaway. It's CGI. And for me, personally, for some reason, it's the first thing I notice in a scene, so I just try to kill that right off the bat because I already know. Octane is actually working on nodes that will just automatically scramble your material and keep it from tiling, so that's really exciting. But for now, we kind of have to do a little convoluted workflow. So what we have is 2 Octane glossy materials, and on the first one, we're piping this roughness grunge map. We're using a transform node, and this image texture is being added to this image texture, and they're making this one together, and that is driving a displacement node, which I didn't end up connecting to anything because I didn't want to, because it gave me some hot pixels. So I just said, okay, that's good enough. Let's drive it through the bump. It was a little too much bump though, so that led me to kind of clamp these values down right here with a gradient map, so it wasn't so noticeable. I wasn't looking for that. And the same thing here, we have this right with our same transform node piping into another gradient map because our roughness was a little too extreme for me. And then I just remapped that grayscale image to make it less intense. I was really looking for these super hot highlights, and I wouldn't have gotten that if I would have done complete white value on that. So that's what's going on there. And then our second material right here, same story. We got our transform, we got our image texture. I like to mix image textures and noises a lot together because noises are super random, but they're a little too random. So I like to mix them with grunge maps to kind of give them that hint of like a surface. And a lot of these grunge maps, and I'll just show you in Bridge because I like to use Bridge for all my stuff. Let me pull up a grunge. A lot of these grunge maps will have like a specific thing they're used for. So these are just grunges, but like this one's rust. So if you're working with metal, hey, use a rust one. Rust. Screen's getting all locked up right now because of all the rendering and screen recordings going on. Rust, leakages, and then we get into more niche stuff. There's some scratch ones too. There's scratch rubber, I know for sure. Oxidized, coated steel. That's super specific. I like that how it's so specific it is though. So I'm gonna download these because I'll probably use them in a future project. So yeah, go through, get your grunge library built up, whether it's through Quixel or Polygon, whatever you're using. But just letting you know, hey, it's there. And I like to mix them with my noises. Usually gives me a good balance between complete randomness and some actual story behind the material, like a grunge scratched. Like you want certain things to have scratches. That's really hard to get out of noise. You have to do some crazy scaling and stuff. So that these two materials are leading into our mix material, and then our mix material is what is kind of piping these two together, and then you just define the amount you want it to mix by. So what we have here is a noise that I transformed with a gradient, a crazy gradient. I got the best result from this, and then color corrected it. I think I took away some contrast, it looks like, and then that's just how much these two are mixing. So to see how much they're mixing, if you used Redshift before, you just pipe this. You can hotkey it to output just this, but in Octane, you just click solo right here. And now we see, okay, so where it's white, the other material is coming through, and where it's black, this material is coming through. So if we added more contrast, it's not really doing it for us. Solo node right there. We can like remap how these two are going together. So we can drag this down, pull this forward. You can see how it's all shifting a little bit. And again, we could also do that for, like, let's say we want to look at our bump, maybe our bump. And I actually did this because I was trying to troubleshoot what material was giving me the issue. So I would solo them like that. And there we go. There's our bump of noise right there. Okay, so maybe let's say it's not that. Maybe it's this. Maybe this texture is tiling too much. Let's solo that node right there. No, it's not. But if you wanted to see, we could transform it and make it bigger, make it smaller. And there you go. You can kind of just see. So that's a great tool for troubleshooting materials and seeing what could be improved on them. Another great thing to do is with these full materials. So we're working with textures, you solo. Working with materials, you can click preview mode, and it will bring it into snap you to this, and it will kind of give you, hey, this is what it would look like on this like greeble surface. And then just to get out of that, you just click disable preview mode, just like that. And again, there's some other useful things. If you left click, you can select hierarchy, and then you can move them all together. That's great for organizing your nodes, because I, for one, can overdo the nodes and get a crazy spider web. Sometimes I get frustrated with that, so I just start to organize them. So that's a great way. There's also all these disable node, enable preview, pins, save as preset. Really, really fun. So yeah, you have all that there. I could save this whole structure if I wanted to and never have to make another floor material because I'm happy with this one. Oops. Okay, so for some reason, Octane kind of got stuck on that. Maybe it was something I did. I might catch it in the recording, or maybe it was just a little bug that they have. They have quite a few of bugs right now. But it is what it is. Like I said, they're working on fixing that kind of stuff. So if you run into some issues with it, it's part of the process at this point. So yeah, make sure you're saving all the time. Make sure your autosave is on. That's my best advice to you. Real quick, let's just jump on this material, this beautiful blue material. I accidentally created this. Honestly, I was going for a gold, but kind of moved to this. So right here we have a grunge texture, and we're triplanar mapping it. So let me solo that mode. And I probably shouldn't have done that. I'm just not going to do that because it's giving me these weird results. But basically what a triplanar is going to do, and you can do different textures, it's going to project a x plus, x minus, y plus, y minus, z plus, z minus texture from basically what it's doing is creating camera on every axis and projecting a texture from there. And really what that allows you to do is not have to UV wrap all your stuff. So if you're a weird shape like this, no more UV wrapping or unwrapping. You could just use a triplanar node. I got this grunge 8K texture from Quixel, triplanar mapping it into the specular and the roughness. And then just this RGB IOR. And then I just literally just accidentally created this. And I was like, that looks really cool. We can slide it around. And you can see we get different results. Just like that. And this is how you would create metal materials. We'll talk a little when we get into it. You can actually get like scientific values from materials to recreate them. So yeah, and then you like have their fall off right here of how they fall off. So yeah, and we'll talk about all that later, but just letting you know, hey, this there, that's how I made this material. If you want to open up this project, look around a little bit, you can do that. And then I'm just gonna left click on all these and click delete unused materials, so we're not loading anything extra in. And that's a really deep blue now, so I'll just kind of revert that back later for y'all. But I just wanted to touch on everything in this scene, play around with it, guys. And if you want some homework for this chapter, I mean, by no means you are obligated to do it, but it would be really good to practice creating floor materials and having them not tile where you can see them tiling, have them kind of break up. Also just play a little bit around with that material, and you can mess around with lighting. We'll touch on lighting in the future though, so by no means are you obligated to. If you're pretty comfortable in Octane, go ahead and just move on or go through it. It's up to you, but this is really just an introduction into all the little features, all the we're kind of touching on what we're going to be diving into in the future. Obviously, I didn't touch on this, but hey, there's the Octane camera. We'll have a whole camera section because this is really powerful. But yeah, that's kind of a lot of information to throw at y'all, especially if you're a beginner. So feel free to rewatch this. Feel free to follow along and kind of break apart this project file if it seems complex to you. It's not, trust me. And if it is, hey, it's okay. You're just now a beginner. It's totally cool. And then just try to create something cool. Play around with lighting. This is a really simple scene. 2 lights, 2 materials, and 2 objects. What more could you ask for? So yeah, that's that. With just that stuff, we were able to create something pretty beautiful. So that's really, and it should be encouraging to you if you're a beginner. You're not that far away, and by the end of this, you will be there, because we're going to dive into the creative side. But yes, this is the end of chapter 1. I hope you enjoyed it. Digest all that if it was all new to you, and then we'll be moving on to chapter 2.